Hello everyone, and welcome to the 4.2 notes on applying congruence in triangles. So the objectives of today's lesson is to be able to write a congruency statement for a pair of congruent figures, to identify corresponding parts of congruent figures, and to use properties of congruent figures to calculate a missing side and angle measures. So let's begin with some vocabulary, and the first thing we're going to talk about is congruent figures. So when you have two or more congruent figures, what that means is that they have the same size and shape. So same size and shape. So basically what that means is that they are mirror images of each other. If you took one shape, place it on top of the other one, they would line up perfectly. Now, corresponding parts are parts that are in the relatively the same position. So parts that are in the same relative position. So if you think back to last chapter, we had corresponding angles when you had parallel lines that were intersected by a transversal. Corresponding angles were in the same relative position with respect to their own little cluster of angles. All right, so the first example here, we want to write a congruent statement for the triangles. We want to identify all pairs of congruent corresponding parts. So your congruency statement, what you're going to do is say which two triangles are congruent. So I could write my first one in whatever order I choose. I could say triangle A, B, C. I don't even have to give it any thought. I just write that triangle in any order that I feel like. But then the second one, you have to follow the order of corresponding parts for the second one. So notice here I went A to B to C. That was the order that I took. So I always look and I'm like, okay, triple arches, single, double. I have to write the second one in that same exact order. Triple, single, double. So it'd be triangle D, E, F. So now when I write corresponding angles, I don't even have to look back at the picture because I made sure to write it in order of corresponding parts, my congruency statement. I know that A goes with D, B goes with E, and F and C go together. So angle A is going to be congruent to angle D. Angle B is congruent to angle E. And finally, angle C is congruent to angle F. And I could do that, again, like I said, I don't even have to look back at the picture. I just know because the order that I wrote my congruency statement is consistent and corresponding. I don't have to even think about it. I just write it that way. So now this last part of this problem asks me for corresponding sides. So notice the triangle, has sides that are segments. So again, I could look at the picture if I want to, but I really don't have to because my order of my congruency statement, it's in order of corresponding parts. So I know AB goes to DE. So I'll write segment AB is congruent to segment DE. BC is congruent to EF. And finally, the last two sides are AC goes to DF. For example 2, same type of problem. I want you to notice that in example 1, the orientation of these triangles was identical. It's like you took triangle ABC, copied it, pasted it right next to it, just relabeled the vertices. This one is different. It gets flipped, rotated, maybe reflected. So again, when I write my congruency statement, first triangle, I write however I feel like it. So I'm going to write JLK. Now the second one, I have to be careful because I have to go in that same exact order. So notice that I did from J to L to K. Now you could think of this again. This time I'm going to do it as far as sides are concerned. So I went down the triple tick marks to double. I have to do that same thing for the second triangle. So triple to double. Okay, now if I preferred, or if you preferred the angle method of thinking, okay, like how many arches were in each angle, you could do it that way, or you could do by side markings. So triangle JLK is going to be congruent to triangle TRS. And again, just glancing upwards, I see that J goes with angle T. The middle angle L is going to go with the middle angle for the second triangle, so R. And then angle K is going to be congruent to angle S. Sides, same thing. Just looking at my congruency statement, I can write which sides are corresponding and they're congruent to each other. So JL is congruent to segment TR, or side TR. LK goes to RS. And finally, JK is congruent to TS, that side. So how do I do that? Just really quick to reiterate, first two letters go with the first two letters, the second two go with the second two, and then first and last to first and last. All right, example 3, all we're doing is writing congruency statements for each of the following. So let's see for the first one, first triangle, write it in whatever order that you want. So if I write triangle D, G, E, I have to follow that same order for the second one. So it's going to be triangle. So let's see. I went from right angle down to no angle to E. I'm going to go right angle to no angle to the arch, I guess, because I went right angle, no angle, one arch, right angle, no angle, one arch. So F, E, G. Second one here, notice that the triangles are actually not congruent because this one on the left has a single ticks and this one has double. That means that they are different sizes, so you would say not congruent. I'll be honest, that doesn't happen as often. Usually they are going to be congruent because we want you to be able to write a congruency statement. All right, pause the video and try this last one on your own, and I'll just display the answer. All right, so what you should have gotten is XYW is congruent to triangle ZYW. Your order does not have to be exactly the same as mine because, again, you could write your first triangle in whatever order you want. I could have written it as YXW. I could have written it as WYX. That's just up to me. But what you should be checking to see if you're correct is X here has to go with Z. So if X is your second letter of the first triangle, it should be the second letter of your second triangle. Y is my second. Y is my second. So they should be in the same spot, and then W and W obviously go together. So again, as long as it's consistent and you're lining up corresponding parts, the order of the first one could be different than mine, but then your second one also has to be different than mine. All right, example 4, we are given that in the diagram, this quadrilateral DEFG is congruent to quadrilateral QPSR. So for part A, we want to find the value of X. So the first thing you should do is go to your picture and see where X is. X is right here. It's inside of an angle, and it's inside of angle E. Well, now I have to know what that corresponds to in the second quadrilateral. So notice E here is my second letter. I look to the second letter here. It's going to equal P. So I'm going to set up my equation, 1/2 X plus 4 is going to equal 62 because these segments, or I'm sorry, because these polygons are congruent, their angles are congruent. All their parts are congruent. So 1/2 X, subtract 4 from both sides, I get 58. Multiply both sides by 2, and I should get X is equal to 116. I could plug it back in, do half of 116, add 4, and I should get 62. Part B of this example tells me to find Y, so I have to locate Y. It's not in my first quadrilateral. There's no Y's there. Oh, but here it is in my second one. It goes with RQ. Notice RQ is first to last letter, so it has to go first to last letter of the first quadrilateral, so it's going to equal whatever DG is. All right, so I set up my equation, 2Y minus 3. Is going to equal 10. They have to if these are congruent polygons. So 2y, I'm going to add 3 to both sides. I get 13. Divide by 2, I get y equals, you could either write it as 13 halves or 6.5. Example 5 down here, we're given that the triangles are congruent. We want to find the values of x and y. So again, same idea. They told me ABC, triangle ABC is congruent to triangle DFE. So if I want to find x, x is inside of angle D. D goes with A. So I set up my equation, 5x plus 2 equals 87. Subtract 2, get 5x equals 85. Divide both sides by 5. And you should get that x is equal to 17. All right, I'm going to do the same thing for y. I have to first locate which angle y is in. It's an angle C. Look to the congruency statement to see that C corresponds to E. So 3y is going to equal 42. Divide both sides by 3, and we get y is equal to 14. Okay, example 6 is a little bit trickier just because you're not given exactly the information you need right off the bat. We're going to find the value of A and B. So A is inside of T, which means it's going to go to H. So 6A minus 3 is going to equal what H is equal to, which is 51 degrees. Add 3 to both sides, you get 6A equals 54. Divide both sides by 6, A is going to be equal to 9. Let's do the same thing to find B. B, notice this little arrow is pointing right there. It's angle K. K corresponds to S, and if you look over here, we don't have S. So we're going to have to find S. How are we going to do that? We're going to use yesterday's lesson, which says that the angles of a triangle add up to 180. So we know that angle T is 51 because it goes to H. We just said that in the previous example. So I'm going to add 83 and 51 and then take that sum away from 180. So in this triangle on the right here, angle S plus angle R plus angle T has to be equal to 180. So let's write that really quick. The measure of angle S plus 83 plus 51 has to equal 180 degrees. So the measure of angle S plus, if I add 83 and 51, I get 134. It equals 180. So the measure of angle S is equal to 46. All right, so I did that so that I could find B. So notice my blue angles that I circled here. 7B minus 10 is going to equal 46. Add 10 to both sides. 7B equals 56. Divide by 7. B is going to equal 8. Okay? All right, so now that brings us to the third angles theorem, and this says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. They have to be, because they all add up to, in each triangle, they add up to 180. So if two are congruent to two in another one, the third ones by default have to be congruent to each other. Example 7 here then, we are finding the measure of angle BDC. Notice that BDC is this angle of the right triangle. If you think of these as two overlapping triangles, so it's that one. So now I notice that angle B and angle A are congruent, and I know that because they both have one arc in it. So, and then these double arc angles are congruent. So what I'm going to do really quick is just redraw this triangle, BDC, to make it a little clearer what I'm doing here. So I know that the top angle, angle B, like I said, is congruent to angle A. So it is 45 degrees. This bottom angle here is equal to this bottom angle over here, so it's 30. So now I know that the measure of angle D plus 45 plus 30 is equal to 180. That's the triangle sum theorem from yesterday. So the measure of angle D plus 75 equals 180. The measure of angle D is going to be 105. And again, I called it angle D, but it's actually the measure of angle BDC because that's what they wanted me to find. I just relabeled it, so it's 105 degrees. All right, next thing we're just going to touch upon slightly, because we're not going to be doing proofs too much this year. You may have to do a fill in the blank once in a while, but not very often. But these next three properties work for triangles, for angles, for segments, for numbers, for letters. The reflexive property, so if we're talking about properties of congruent triangles, reflexive property would be triangle ABC is congruent to triangle ABC. It's like a reflection. What you see in the mirror is you. It doesn't become somebody else. It's reflexive property. Okay, symmetric is saying if you have two triangles that are congruent, so triangle ABC is congruent to a totally different triangle, so let's call it DEF. Then triangle DEF would be congruent to triangle ABC. So notice all that I did was switch the order around the congruency sign. The first one, ABC, was first, and then DEF, and then I just switch it. Common sense. It doesn't matter. You could switch things around an equal sign, around a congruency sign, and not change the equality or congruency. The last one here is called transitive property. So transitive starts with the T. It's going to involve three things. That's how I always have students try to remember it. And this says if triangle, and let's say ABC is congruent to triangle DEF, and triangle DEF is congruent to some third triangle. That's why there's three things. Let's call it XYZ. Then, so what this property is saying is if you have ABC is congruent to DEF and DEF is congruent to something third, you could kind of get rid of that middle guy and say then triangle ABC is going to be congruent to triangle XYZ. Okay, so just familiarize yourselves with those property names. All right, the last little piece that we're going to talk about here is we're going to do a fill-in-the-blank proof. This chapter, like I said, used to have so many proofs in it. It was our heaviest proof chapter. We've taken most of them out this year. The only ones you'll see are ones that are fill-in-the-blanks. So notice here that this is the setup for a two-column proof where in the right or the left side of the columns you have your statements, and on the right side you have your reasons. So we are given a bunch of information here. They gave us a bunch of givens, and then they're saying, okay, well, you need to prove that these triangles are congruent. Well, we just said in order for two figures to be congruent, all their corresponding parts have to be congruent. So we're proving two triangles. They gave us two angles from each triangle that are congruent. Then they gave us two sides from each triangle that are congruent. That's a total of 4 different pieces that are congruent. And we know that if triangles are congruent, all 3 angles, all 3 sides are congruent, so we're missing 2. So let's go ahead and see what they put in the proof. They marked in the picture what's congruent. So segments with tick marks, angles with arcs. So we have our 4 things that are congruent. We need 2 more. So in a two-column proof, you always start your first statement is all your givens. The reason that you know that's true, because the reason you're making an argument of why what you put in the statement column is how you know that that is in fact a fact. You have to argue your way through it. So the only reason we know that these angles and sides are congruent is because it was given to us. So the first reason in a proof 99.99999% of the time is going to be given. All right, so the second thing they told me, or that's in the statement, is that BD is congruent to BD. Well, if you look at these two triangles, they're kind of flat up against each other. They're back to back. They share that side. But then what would be this reason? This should look familiar to you. We just did these properties on the other side. It's reflexive. So now that's with the 2 given sides that they gave me in the third one. That's all 3 sides. Last thing I have to prove is the angles that aren't marked here. Well, the reason they gave me here is the third angle theorem. We just talked about that on the other page. And it said that if 2 angles of one triangle are congruent to 2 angles of another triangle, automatically the third angles become congruent. So here I would say what those third angles are, and it's angle A is congruent to angle C. Notice now in my picture of the 2 triangles, all 3 sides are congruent to all 3 sides of the second triangle, all 3 angles to all 3 angles. That is enough to prove these triangles congruent. So I could say without a doubt that triangle ABD is congruent to CDB, or CDB. Reason is definition of congruent triangles. Okay, we said that triangles that are congruent have all three congruent angles, all three congruent sides. I just proved it. Done. All right, so did we accomplish the objectives? Would you know how to write a congruency statement for a pair of congruent figures? Could you identify corresponding parts of congruent figures and use properties of congruent figures to calculate missing side and angle measures? So we're going to do that right here. We want to solve for x in this example. It's an angle inside of a triangle, so I know that these three angles are going to add up to 180. So 2x plus 60 plus e. Well, what is e? It shows that it's congruent to this triangle angle C, so it's going to be plus 70 equals 180. So 2x plus 130 equals 180. Subtract 130, 2x is going to equal 50. X is equal to 25. This last page has a few extra examples. I think the first one and the second one are actually ones I already did. They're copies of what we had already. And then example 3 and the challenge your teacher will do with you in class tomorrow. All right, thank you so much for watching. Have a great day.